This is design task 2. Let's start by looking at the first diagram. Here, we see a simplified traffic light control system. The input signals include switches for a train, a pedestrian, and a car. These switches can be either on or off, representing the presence or absence of these elements. The main state flow chart in the middle processes these inputs to control the traffic lights. The output signals control different aspects. Flash, 4 flashing warning lights. PED green, 4 pedestrian crossing lights, and green, 4 regular vehicle traffic lights. Notice how each input activates a different output based on the conditions programmed into the system. Now, let's move on to the second diagram, which represents the state flow chart. This chart depicts the main states that the traffic light system can be in car_BTN, train_BTN, and PED_BTN. The car_BTN state is the default state, where vehicle traffic is flowing normally, and the green light is on. In this state, the flash and PED green signals are off, while green is active. The train_BTN state represents when a train is detected. In this state, the flash signal is activated, indicating to vehicles that they should stop. PED green and green signals are turned off to ensure safety. The PED_BTN state is triggered when a pedestrian is present. Here, the pedestrian crossing light, PED green, is turned on while both the flash and green signals remain off. Notice the conditions for state transitions written on the lines. Train == 1 indicates a transition to the train_BTN state when a train is detected. PED == 1 triggers a move to the PED_BTN state for pedestrian crossings. Train == 0 and PED == 0 returns the system back to the car_BTN state when there are no trains or pedestrians. Next, let's examine the third diagram, which goes into more detail about the light control states. Show the third diagram on screen. This chart details how the traffic lights behave under different conditions. Green_light, this state allows vehicle traffic to proceed safely when the green signal is active. The output variables are set to V0 = 1. V1 = 1, vertical light, while H0 = 1. H1 = 0, horizontal light. Flash_red and flash_amber, these states are used for flashing alerts. The lights alternate to indicate caution when the flash signal is active. For example, flash_red has V0 = 0. V1 = 0, H0 = 0. H1 = 0 while flash_amber switches to V1 = 1. PED green, the pedestrian green light is on, meaning the pedestrian can cross safely. Here, all outputs are active with V0 = 1. V1 = 1, H0 = 1. H1 = 1. Use animations to highlight active states and conditions. Pay attention to the conditions for transitions, such as green == 1, which moves the system to green_light. Flash == 1. To enter flash_red or flash_amber. States for flashing warnings. The transition between flashing states uses a condition. Duration, flash == 1, 0.1, which indicates the light flashes for a set time interval. When it comes to flashing lights, timing is crucial. For instance, the condition duration, flash == 1, 0.1, ensures that the lights flash long enough to warn vehicles of an approaching train or allow pedestrians to cross safely. Similarly, the system automatically returns to the car_BTN state when no trains or pedestrians are detected, maintaining a normal traffic flow.